Shall I start then?
Yes, sir. Please start.
Yeah. Hello. Good evening to everyone. I am Srinivas Vasu, running a small institution called Soil Trust to sensitize the general public, the consumers, as well as the farming community about the importance of soil and especially the soil microbes. So I'm working with other institutions and traveling across the state in this context. So thank you very much for agricultureinformation.com for providing me an opportunity to share my views, my experiences about soil, the foundation of nutrition. I hope all of you can see this poster, Soil, the Foundation of Nutrition. And don't go to give much trouble to read those letters in English, which are too small to read actually. But just focus on the images given there. Primarily two images. One is a human being and another one is a plant. And below the plant, consider it as soil. So why I showed you this image? You know, we are all actually working very hard, and because to lead a good life, and especially after this corona, we are more concerned about our health actually. So what exactly is health? Health is nothing but when all parts of your human body, when your body functions very well, then you are considered as a healthy man or a healthy person, healthy human being. That means it is not only the physical, but also mental health. So to be healthy, we need particular nutrients which supports the functioning or activities of the every part of the human body. Each part of the body requires a different nutrients, whatever you call it. So when we have all those nutrients, then only we consider as healthy. So how we get those nutrients? With the food what we consume, with the food what we eat. And the food is coming from the plants. Food is produced by plants. That means if we have to be healthy, we should have a healthy nutrient food set, and the food is coming from the plant. That means the plant also should have those nutrients which support our body function well to be healthy. Then only the different parts of the plant which produces food for us functions well. So the need of a human nutrients for a human being to be healthy is also need of a plant to grow well, to develop well, to grow healthily. Then only the different parts of the plant body, like the roots, the stem, or the leaves, or the flower, or whatever it is, or grains, or flowers, or fruits, or vegetables, whatever it is, it functions well. So from where these nutrients the plant getting from? Plants absorb it from the soil. So those nutrients should also be in the soil. See the relationship. So how the plants will absorb those nutrients? The nutrients will be in the soil. How it will be in the soil? There will be what we apply to the soil, like organic soil inputs like compost or vermicompost or green leaf manure. I'm talking about organic only. So when we apply those things to the soil as a soil nutrients, it will not be in the consumable form by plants' roots actually. It will be still an organic matter. There will be some activities takes place once we apply organic manure to the soil. That means the life within the soil. Some of them are can be seen with bare eyes, and some can be seen only through microscopy. And this organic material is food for those soil life, and they consume and they transform whatever they have consumed the organic material into organic matter that slowly transformed into nutrients. Why I was particular about this poster is because if we have to be healthy, there should be life in the soil, and we have to nurture that life in the soil. So our health is directly depending on the life within the soil. So there is no life if there is no there is no human life if there is no soil life. So no soil, no life. This is what I wanted to convey to you. So now, as soil have all those living organisms within it, now we have to call it as not just as a soil or a dirt, but we have to call it as a living soil. Okay, let me go to the next one. I have a little, I mean, a larger, the contents of this, but I will go for about half an hour about showing this. Then we can have a dialogue discussion. So soil, it doesn't mean that it is only providing us food. It is one of the non-renewable resource. When we say natural resources, most of the people actually fail to mention the name soil. They don't even consider it as a living thing, as a natural resource. But it's unfortunate what it deserves, it is not getting. And it is produces the food, the feed for the animals, and the clothes what we wear. It is giving us the shelter. It is also producing energy, everything. And it actually stores the rainwater and filters and take it much down, down at the, as a, water storage within the soil. Then whatever the waste we put on the soil, it will be transformed into nutrients. And we know that on our earth, the 3 parts are water and 1 part is with the land. And this entire land is with the soil, which is hosting a quarter of our planet's biodiversity. This is very important. So soil is playing a much bigger role than we consider normally. The third, soil makes it for you because we have to study, we have to understand soil because we have a lot of benefits from that. It is the medium of crop production. It is the producer and the absorber of the gases. It is a medium for plant growth. It is home to organisms like plants, animals, and others like insects, trees, everything. Okay. Then it is a great integrator, so that all parts of the ecosystem actually comes under soil only. Soil will take care of it. Then the snapshot of the geologic, climatic, and biological and human history. Even soil is studied to understand the human history, to gauge the biological things, to understand the climatic variations. And it's a waste decomposer. It is a source material for construction, medicine, art, etc. It filter of water and other waste actually, and it is an essential natural resource. So study of soil is nothing but study of the physical and the biological components of the soil, which is what I am focusing now on. I am traveling across the state and visiting farmer associations, institutions, NGOs, and trying to provide whatever the information and experience I have related to soil. When we say the soil, for example, if we say agriculture, you talk about biodiversity, you talk about climate change or energy or forest or gender, whatever it is, all these are linked to soil quality. So we have to think about that. Soil is linked to everything what we are doing, everything required for our daily life. So this is very important. So there is a need to do a kind of a study about this, the physical and the biological components of the soil. Now, when we say who is growing crops, we say farmers are growing crops. Yes, it is fine, true also. But at the same time, farmer cannot grow crops without soil. He cannot grow crops without sowing seeds. He cannot grow crops without rain or whatever water. He cannot grow crops without the manure. Manure comes from the animals, farm animals. And even after putting the manure, that has to be transformed into nutrients, as I told you earlier. So he cannot grow crops without soil life. So in a way, farmer is a direct, what you say, the partner of farming. But these are the silent partners which are supporting farmers silently. That's why we call it them as silent partners, but which are playing a bigger role, a vital role in producing crops. So this is very important. And the rhythm of this, the soil, the water, the seed, the animals, the dungs, the organic matter or manure and the soil life here, all these things combined together and which goes in a rhythm and produces diversified crops here, what I'm showing here. So this is very important. When we don't value the contribution or the roles of these silent partners, there comes the problem with the agriculture, production. So that is the problem right now we are facing. I have given you, you have seen two different images here. To the left, this is a traditional old village image where we can see the, what you say, the partners of the agriculture, silent partners we have here. And to the right, now we are facing severe problems, especially the challenges in agriculture. Now, there is a problem of low soil fertility, and the climate variations is there, vagaries of climates, and which is making a severe impact on the crop production. We are getting, yield is lowering year after year, and we are also having the shortage of land. So this has to be addressed. How we have to address? Number one, as I said, rain plays a pivotal role in farming, especially in the soil and other things. But how much rainwater we are using effectively? For example, if we say, I am a person who is a farmer and I am growing only a monocrop or a single crop here. To the left, what we are seeing here. The person next to me, the neighboring landowner or a farmer, he is growing multiple crops. So how effectively I am using the rainwater? I am not at all using the rainwater effectively because I am growing only a single crop or a monocrop crop. And when there is a rainfall, it only part of the plants will absorb it. All the remaining will fall on the directly on the soil, and soil will be disturbed. Their structure will be disturbed. The more rain, it will affect the soil, presence there. And if the land is too gradient, the topsoil will also go away out of the land. So it is not just the topsoil going out of the land. It is the soil nutrients, whatever there, that is also eroding. And whatever the life in that soil, that is also eroding. But to my neighbor farmer, if you look at him, he is growing multiple crops. And in these multiple crops, you can see the root system of each crop is so different. Some are very shallow, some goes much deeper. We can see all these things. So every drop of rainwater actually falls on this first, and then slowly falls on the soil, which doesn't disturb the structure of the soil. And slowly, because of the root which we created the tunnels there into the soil, inside the soil, the rainwater goes into the soil downwards, and there water base will be developed. So this is the important thing when we talk about soil. If we have to conserve the soil, we have to conserve in such a way that not even a drop of rainwater should go out of our land. In Bangalore yesterday, we had a very severe rain. Just I'm giving you an example. They say in 1 centimeter of rainfall gives around 40,000 liters of water in 1 acre of land. That means in 1 acre of land, if there is a 1 centimeter of rainfall, that is equal to 40,000 liters. Even if we remove 30% out of it due to the weather, due to heat, or due to for other reasons, at least 28,000 liters of water should go into the soil. But is it happening? No. because our soils do not have that absorbing capacity. They have lost their absorbing capacity. Our soils do not have the capacity to store water now. That is why, because soil has become so hard here, as I showed you, if you look at the left image, this is the thing. A white patch is there. And this patch, this is a hard pan where the plant roots have failed to break that pan to go much deeper into the soil. That is because of the monocropping. So all these things has to be observed. And what is happening? This is just happening not only here. We want to study. It is not that how much rainwater flow out of our land eroded. It is also how much topsoil have eroded from our land, because topsoil is the primary thing in crop production. If there is a topsoil, there will be a crop. Otherwise, soil will become so hard. So this has to be addressed carefully. So they say, no, is it the drought is because of the bare ground, or is the bare ground because of the drought? They say it is not that drought is causing the bare ground. We have left our land fallow. We have left our fields fallow. That's why drought was created. That was the reason. Otherwise, why drought should have been there? So this is very much linked to the how we are taking care of our soils. That's why I showed. And look at this image, salt affected soils. Though we have given quality, or they say hybrid seeds, and we apply a lot of chemicals, fertilizers, everything, and we also have a lot of irrigation facility. Still our plants are not growing well here. With all those things, it is almost like that, you know, if you look at some of the black cotton soils, the entire soil will be so wet, it will take weeks to get dried up actually. But even in that situation also, there is water, but still our plants are not growing well, because after application of the salt, that is, salty fertilizer, chemical fertilizer, or the water will dissolve it actually, and then the entire water will become salty. So how can a plant can sustain in a salty water? This is the problem. So this has to be addressed to reshaping our soils. So why with all those things we say we have very good information and data in our country agriculture production, they all give a classy flowery pictures that we are producing that much of ton and exporting, all such things. But still in the rural areas or even in the urban areas, our children, our women, our seniors, ourselves, we are all actually not so healthy because we are malnourished. It is not that the food which provides you health. It is the nutrition food. So we should talk about not food security, we should talk about nutritional food security. So when our soil do not have those nutrients, as I showed you in the beginning, how can a plant grow well with a lot of nutrients? The soil itself, the base of the plant is soil. When the soil itself is lacking nutrients, so the plant cannot produce nutritious or healthy crops, healthy food. So a nutrient depleted soil cannot produce food that contains those macro and micronutrients necessary for our health. This is very, 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 very important. So in this context, actually, when we say soil, most of us think that it is the problem of the farmer. Why should we worry about it? Actually, it is not. All the consumers, everyone on this earth who can think, who can do something, have a role to play to conserve the soil, because we are all depending on it. So in this context, there is a need to understand soil in a much deeper level. For most of us, soil is like a dirt. It is a dust. We never allow even our children to touch the soil. Forget about playing in soil with soil. We don't even allow the children to touch the soil. because it get, the children will develop some kind of problem, health issue, something like that. But soil do have lot of nutrients. Along with that, it also have lot of life, especially certain bacteria, which are very, very, very important to protect our body. That will build a kind of a immunity among us within our body system. So we have to understand those things. So a touch is worth more than a look, they say. So looking at all these things, can we consider that our agricultural soil is really uh, fit to grow plants? We call in Kannada Namma Mannu Krishige Yogyave, whether it is really fit to grow crops. So we have to think about all these things, and that is why we have to talk about soil. We have to redefine it, we have to redesign it, and we have to reshape it actually. So this particular interaction, what I am having with you all, thank you very much. This is an opportunity. We have to talk about reshaping our soils. So what exactly is reshaping our soils? It is just nothing but understanding the pulse of my soil. Like any other living things, the plants, the animals, the humans, the insects, the trees, everything. Soil do have life. So when there is a life, there should be a pulse now. It should have some kind of a pulse now. That has to be understood. That has to be gauged. That has to be realized what exactly it is. What is the rate of pulse beating or something like that when we examine the pulse beat of a person. Similarly, we have to look into the pulse beat of the soils also. So this is the way we have. This can be done in 4 levels. Number 1, understand the pulse of my soil means that understand what is the sand, silt, and clay contents in my soil, and what is the available organic material in my soil. So it is very easy to a small bottle. We have this water bottles, which are 1 liter water bottle or half a liter of water bottle. We can take a part of the soil from our surface of the land, soil, and we can half of that we can put. I will explain you later. And we have to fill water to 3/4 of the bottle, close it and shake well. This is called, we call it as water bottle method, where to know the percentage of sand, silt, and clay contents and organic material in my soil. This is the first thing. After knowing this, we are going to look at the characters of my soil, especially the physical and the biological components. Why characters is important? Because the physical components of the soil also gives us a lot of indicators that how my soil can perform, how it can perform to produce crops. Our aim is to ensure that to transform our soil into a fertile soil so that it can be productive, it can produce plants. So in this context, we have to look at the physical and the biological status, like the color, smell, residues, there are roots, the pores, all such things. We have to look into the physical components. Biological in the sense, what are the living creatures we can see with our bare eyes, and some of them can be seen only through microscopic, and those are the things. So first, understanding the components. Second one is understanding about the characters of my soil. The third level comes there, that the soil qualifiers. That means for any soil to produce plants, it should have 3 major M's. What we call it as matter, moisture, and microbes. So this is very, very important. So to ensure, you need not ask anybody else. To ensure that your soil should produce plants, you should only think about the matter, organic material it is having, and the moisture it is holding, and whether there is life or not in that soil. So in this context, we have to look at the soil as soil qualifiers. And the fourth is the dimension. That means how we improve this matter, moisture, and microbes by conserving and qualification, pollinating, and regeneration. There are so many ways of adding organic soil organic inputs to the soil in different ponds with locally available resources. So this is very, very vital for us. And as I told you, this is a bottle thing, what we can see. They say when we do this soil testing, bottle method, when you test the soil structure, normally most of the plants grow when the soil have an ideal composition of 40% of sand, 40% of silt, and 20% of the clay. That is the ideal composition for most of the crops. Certainly, some kind of changes are there which can bring to the normal in this combination. So that is the reason why we should talk about the soil. No, this is nothing but studying the soil, understand the soil. This is very interesting, actually. Okay. And the soil composition, as I told you, sand, silt, clay, and oil composition. This is what I told you. Because the sand, the silt, and clay, each one plays a vital role in holding water, holding organic material, holding soil life, and all other things. So this is very, very much important to begin with, actually. And soil particle sizes. Here I will show you the small dot here. The small dot which within that blue thing, that is a clay content. It is so small. And little, bigger that circle is the blue circle. That is the silt, and the big one is the sand. So these are the components. When you do the bottle method, you can easily see. Look at here at the bottom of the bottle, the sand normally will be settled. Above that will be silt, and above that the clay content. So this is very important and very easy to understand it also. And also some of that's what I call, visual and practical. It is measuring the soil to manage it, like that we say. So this is the beginning of the visual and practical aspect. So take soil, a handful of soil, and try to observe it, what is there or not, whether it is dry, whether it is with a faded color or little dark in color, whether it absorbs water, whether there is life in it. All such things can be done. The second one, as I told you, is about the characters, the physical and everything. So look at all these four pictures. This is what we need to observe the soil, whether it is holding the plant roots. Sometimes when you take a plant, the roots also come along with some of the soil also. It will be so interlinked that it will be difficult to break them, actually. So we have to look at all these aspects, to understand the physical as well as the biological components. The more organic matter, the more decomposed organic matter, which actually indicates in the form that on certain soils, when there is a lot of organic matter which have decomposed completely, and there will be a small, a small black content will be there, spots like that. Those are all the actual nutrients. Okay, so these things has to be checked in. And the third one, as I told you, the physical component is very, very important. By doing visual and practical assessment, we will understand the conditions of their soils and develop skills to improve them. The soil structure through water bottle method, the color, the smell, the aggregations of silt, sand, and clay particles, surface organic material, residue decomposition, compaction, workability, porosity, water infiltration, drainage system, water holding capacity, erosion level, crop appearance, plant roots, root mass, and we also look at that, how much water absorbing capacity. Okay, it is not just water infiltration. How much it can hold water? If there is a one soil sample, if we take and if we put it around 50 grams of the soil sample, you put it in a funnel which is decorated with this particular filter paper, and put 50 grams of water, soil, and add 100 ml of water, and observe that how much water came down. The water, the percentage of the water came down is that the water 100 out of 100 ml, if you have only 50, which have come 50 will come out from the soil, then your soil have only 50% water absorbing capacity. So if there is 1 centimeter of rainfall, that is equal to 40,000 liters of water, your soil have only 20,000 water absorbing capacity, 20,000 liters of water absorbing capacity. So these things can be done with small experiments, and if you involve students and children and farmers, these things will be very good actually, to understand the soil at a much more deeper level. And look at these friends and creatures. Actually, we have seen all these things, but probably not so many people have given a prominence to observe it, prominence to understand why it is there, what it is doing. For many farmers, unfortunately, all these moving living organisms of the soil is like a pest for them. They think that it is there to destroy the crops, so they immediately apply pesticides or other hazardous chemicals, deadly poisons, and sometimes weedicides also. So that kills everything. So soil life will be, completely devastated. They lose their life because of chemicals. So there is no movement in the soil. There is no life in the soil. Our soil also will become dead. So this is understanding soil organisms or soil habitat is very, very important. And I will tell you, each and every soil organism which are visible to our naked eyes and which are microscopic have a specific role to play, specific services to do to improve the soil fertility. So we need such kind of soil organisms or life in the soil, and we need it not at once. We have to create a kind of an atmosphere for these soil organisms to settle there. So we have to create a habitat for them. So we have to feed them regularly, otherwise they will die without food. So this is the actual challenge of managing the soils. So that's why I call this, it is the factory of life. Why we need the soil biodiversity? Because it is factory of the life, working throughout the day, 365 days, 24 hours, 7 days, 365 days, whatever you call. Throughout the day or night, it is going on working there. So this is very important to understand. And a lot of diversity of soil organisms reflects the mix of living organisms in the soil, and they interact with one another with the plants and with small animals, and forms a web of biological activity. And the soil food web includes the earthworms, spiders, ants, everything is there. So I am actually interested in every school, in every college, or in every gram panchayat level, we have to have a kind of a museum, so that we can exhibit the types of soils we have, the types of living organisms within the soil. Some of them are microscopic, as I told you, only through microscope we can see. But those images can be, enlarged 10,000 times or 50,000 times bigger than the actually size. Then we have to hang it and try to give little information about those things and what they do, what are the services, why they are important to us. This is how we have to start educating the general public about the importance of soil and soil life. And the soil life is so important because it enhances the plant growth, it recycles the whatever the waste we put into nutrients, and it is, some of them are nitrogen fixers also, and it protects the plant from different types of viruses, other bad bacteria, good bacteria are there, something like that. And some of the pathogens are there, which are the carrier of something like that. And it detoxifies some of the whatever the soil have, that the toxic elements, it detoxifies them, and it influences the atmospheric composition, and it also decomposes whatever the residues are there, and it filters rainwater to purify it, and it allows water to flow into the soil very well, and it stores water also. And finally, very importantly, the sand, silt, and clay contents, no, all those elements in the soil, they will actually will be aggregated when there is life in the soil, because these life will produce a kind of secrete, a kind of a gum. In that gum, the sand part, the silt part, and the clay part join together, it will binding together, so that it will form as a one aggregation, different types of aggregations like that we can see. So soil biology is very, very important for our survival. So that's why, see, I was asked to, this is very interesting to understand. This is kind of fungi, mycorrhiza fungi we call. What is the white patches, what you see? See, today I was supposed to talk with you, have an interaction with you. So what I did, madam called me and told me that I'm supposed to be ready by 4:45, 4:50, something like that. So how I am somewhere here and she is somewhere there, how we were able to have a communication through that network. She typed my mobile number, and it went there, and I got the signal, we spoke. No? So that network is there above the near, somewhere up. But the similar kind of network is also there below the soil. So that kind of a network is communicating the plants to talk each other, as they cannot talk openly. They have a mechanism to communicate with each other with some different ways. So that kind of a network has been designed or developed or established by this fungi called mycorrhiza fungi. So this is very interesting to understand, to know. It is a fascinating thing of what is happening within our soil, within beneath our feet. Okay. So soil organic carbon. All these things are when organic materials, when we put to the soil, finally it will be decomposed and it will become the organic matter. And part of the organic matter actually forms into soil organic carbon. And this soil organic carbon, which is the real strength of the soil, productive soil. So it supports for aeration, it supports for water retention, it pollutant water actually, it will clean it out, and it will stabilize the soil strength, and it will recycle the nutrients, and a lot of life within the soil can take place when the soil organic content is more in the soil. It improves and increases the productivity level, and also it actually strengthens the soil structure. So the entire, not only in our state, in our country, the entire world is now having a very, what you say, a low soil organic carbon content in our soils. Actually, they say it is supposed to be around 5%. We do not have even 1% also in most of the places, because so the entire program across the globe is now more focus is on improving or increasing the soil organic content in the soil. So that this is the critical environmental functions. So when you have soil organic carbon in your field, your crop develops like this. If you do not have soil organic carbon, your crop doesn't come up well also. So this is those soils with the carbon, those soils without carbon. So there is immediate need to improve the soil organic carbon, which is nothing but adding more organic matter. If I put 100 kgs of soil organic material to the soil, probably it will be around 10 grams of organic carbon might be formed. So we have to keep on adding the organic material to the soil. And the third one is called soil qualifiers. They say, as I told you, about the matter, moisture, microbes, and which in this left image you can see there is a matter is there is a moisture, and there is also life in this. When those things are there, the soil depth will be, the thickness of the quality soil will be more, and which produce a quality plants. And that is the thing. And the entire country or entire globe is now looking into country particular activity, that turning the bare, what you say, the bare soil or a damaged soil into a living soil like this. So for that, adding organic matter is the only way. I am not finding any other ways of improving soil fertility other than adding organic matter. Organic matter can be added in so many ways. So except plastic and fiber and the glass, all other things can be put into the soil so that it will be degraded slowly, decomposed slowly. So what are the three things I told you? Matter, moisture, and microbes to build healthy soils. So this gives the soil color also. Soil color gives an information about the organic matter, the drainage system, the biotic activity, and soil fertility. So this is the matter, this is the moisture, and this is the microbes and other living things to produce a healthy plant, healthy soil. So this is just, the first one is sand, silt, and clay. Second one is physical and biological and chemical components. Third one is matter, moisture, microbes. When all these things work together, we can see miracles in our soils. So this is what I'm going to do. I'm trying to sensitize my friends and others who are into this. Okay, I do not know whether I'm taking too much time. So there are so many ways. They are adding green leaf manure, farmyard manure, compost, vermicompost. All those things are there, which is very easy to make also. Challenging you. It is a skill work. It's a skill-based work actually. And increasing soil carbon capture through rainwater harvesting, as I showed in the video. I'm going a little fast. So we have ministers and the ministries or whatever it is for the departments for water, fertilizer, agriculture, horticulture, forestry, minor irrigation, domestic animals, everything. But we have no specific ministry or a department for soil, living soil. So this is, we do not have even a better policy to safeguard our topsoils, our soil life. So soil biodiversity is overlooked by policymakers and educators, according to me. So we have to work on those things, what can be done. And assessing a assessing a soil means it is understanding the structure, the drainage system, as I told you. This is a little big. I'll finish within next 3-5 minutes. Okay, soil color. So some of the is there. The smell, earth the smell when it rains, soil is an anti-depressant, they say. And surface soil means what is the organic material we find in the soil, at the surface of the soil. And after the leftovers of the crop residues, if we rotovate them and are mixed with the soil, it will be living. Slowly it will decompose and it will die, and it will be completely dead, something they say. So someone was telling living, dying, and dead, something like that. But this is the important activity should take place in our soils actually. And soil organic matter contain, they say, around 58% of organic carbon. But this is a debatable one. What kind of matter, whether it is a wet material or a dry material, which is based on that also. And residue decomposition, we have to look into what exactly is residue decomposition, how it has to take place, what we are supposed to do. It is important to understand the soil organisms, the physical environment, and quality of the organic matter. It depends on that also. Then soil compaction. Sometimes even there is heavy rain also, not even a single drop of water goes into the soil because the soil is so compacted because of the movement of the heavy machinery on our soils. So that has to be looked into. Then workability. Whether I have a land, whether I need a small, bullock plow is sufficient, or I need a tractor to plow. This is so simple. Traditionally, this was used. The farmer is doing this because soil is so soft that he can do it with a bullock, with a plow, wooden plow or something like that. Sometimes our soils is so hard, these bullocks cannot pull that thing. So we need a heavy machinery like tractors. So that is called as soil workability. That also be understood properly. Then good soil structure have different indicators to show us, and soil aggregation. In this is an aggregation of the soil. This is an aggregation. This is an aggregation. This is an. That means in those things, the sand, silt, and clay contents are combined together. Okay, that's the thing. Understanding of a soil aggregation, microbial activity I'm talking about, and porosity. See, when there is life in the soil, it moves in and around the soil, above, below, sidewise. Wherever they move, they form a kind of a tunnel that is so small that we call it as, in the scientific term, we call it as pores. Soil pores or porosity. So when there is a rain, and when the aeration will be there in the soil, which keeps the soil healthy. When there is a rain, the water goes into the soil. That is also very good. So this has to be understood properly. Then the crusting. Crusting is the beginning of the damaged soils. If your soil is getting damaged, this is the beginning indicator. If we don't observe or give attention to it and rectify it properly or address it properly, we are going to face a severe problem. You can see this. Okay, this is called what we call as crusting. But unfortunately, our farmers have not been shown about this. Have not been given information about this. This is the biggest problem challenge. Then water infiltration. Rainwater comes. If this is a sandy soil, the infiltration will be very fast. If it is a loamy soil, infiltrations will be little something like that. If it is a clay content, the infiltration will be too slow, and it will hold the water for a longer period if it is a clay soil, and it also releases water very slowly. So these are the real characters of the soil when you understand. So looking at the soil, whether it have a lot of sand or silt or clay, we have to take decisions about what kind of crop should be grown. Okay, and the water infiltration, as I told you, when the fibrous roots to cover crops break up soil, water infiltration will be more, they say. And water holding capacity, look at this wonderfully. It has an incredible water holding capacity, which have potential to increase water absorption and infiltration. And all such things are there in this. I'm fastening up because of the time constraint. I'm sorry for that, excuse me. So there is, without life in the soil, nothing can be delivered. And it is possible to transform this barren or damaged lifeless soil into a productive soil. That's what the dark color of the soil on the right exhibits the characters of a quality soil. That has to be observed. So plant roots also give us a lot of information about that. So what is the relationship? What is soil? What is root? What is earthworms? What we see? What is the relationship? Such a wonderful, natural thing happening in our. So soil, we getting there. We have to address all those. I think I'll stop here. I'm Vasu, soil tester. Thank you very much, madam. And now I think we can.
Thank you, sir. Thank you. Thank you for a wonderful presentation. I will take up the questions from the participants now.
Can I stop this sharing?
Yeah,
stop
please stop sharing the screen, and it will be good if you on your video.
Yeah, it is not so, only
just try,
for,
sir. Just try, sir. If it is coming, okay. Okay.
Namaskar.
Thank you very much. Thank you.
I am Vasu.
Yes, sir.
Thank you.
I will take up the questions from the participants now. Okay, first question is, which soil is highest in India?
It is black cotton soil.
Black cotton. Okay. Which color is more fertile?
See, color, which color is more fertile? Dark color is more fertile, but sometimes some of the, for example, red soil, when you soak in water, it will become more darker. Doesn't mean that it is fertile. The fertility of the soil depending upon whether it have organic material, whether it is having moisture, and as I told you, whether it is having some life in that.
Okay. How can we protect soils?
Hello?
Yes, sir. How can we protect soils?
we have to protect, number one, protecting soil is the biggest challenge we are having. You know, this NREG work is going on, Employment Guarantee Act. Through that, we can, first, we have to control the erosion of the soil. So conservation of the soil is very first step to be done. So how you conserve your soil? By, if you have a gradient land or a land which is slopy in nature, you have to put bunds or contour bunds we call. Those bunds will not form a straight bund. Those bunds will be normally and exactly in the contour type, cross curve type. So that is the first step. And second step, you have to put a lot of trenches and you have to put, farm ponds or something like that, so that not even a drop of rainwater as a particle of the sand, okay, should go out of the land. So there are many methods of, controlling the soil erosion. So soil, we have to think not only soil conservation, but we have to think beyond soil conservation also to bring life to the soil. Yes. Hello?
Yes, sir. I'll move on to the next question. Can you please tell us about your own background? How did you choose this path?
Oh, yeah. About my background.
Yes, sir.
Nothing so juicy about to hear about me. Actually, I am a son of a professor of physics and maths, but don't ask me how many attempts I took to complete my degree, because I took 2 years to complete my, pre-college course. That's what we call SSLC here, 10th standard. Then I took 4 years to complete my pre-university course. But I never studied soil academically, or I was, though I'm from a farming family, my grandfather used to do farming, not myself actually. Our family, we came back to, we settled in the city. But when I was working with the farming community, when I joined an NGO and started working with them, when I was interacting with the farmers, I was finding what I observed is that they were smiling, actually, the farmers, but their eyes were not smiling. So I was finding it difficult to communicate with them, because I realized that there is some, pain that they are having. It is not a physical pain. It is, it is something related to their land. It is something, they are so worried about their farming systems, the agriculture. If there is heavy rain, it is a problem. If there is no rain, it is a problem. Then marketing is a problem. So while interacting with them, while moving with them for about more than 10, 15 years, then I realized that the real problem is in the soil. Unfortunately for me, I'm a really lucky person, because the institution where I was working, that gave me an opportunity to undergo certain trainings. And I had a great, people like Dr. Adindu Chatterjee, Dr. Narayan Reddy, and Dr. Venkat, and others who are all working. At that time, when I was working, this organic farming movement was slowly spreading across the country. So it was an opportunity for me. We were privileged to be the, first pioneers in that sense. So that was the thing. Then it became a kind of a passion to understand about soil, to know about soil. And now I am cursing myself. I should have studied science. Otherwise, if that would have been there, I would have understood the chemical components of the soil easily. But unfortunately, but my friends say, if you have studied science, then you would not have been here, but you would have been somewhere there, they say. But I love this soil subject. So I'm also learning. I'm also day by day. I'm also learning by doing. So whatever, and please, as I told you, I'm not an academic person. I never studied pedagogy, never even studied agriculture also. But gathered kind of, I was so fascinated about the soil, and most of my friends and gurus, teachers, and my institution made me to realize all these things. I am grateful to them. Thank you.
Move on to the next question. What are the activities in Bengaluru, Karnataka?
Activities of? Hello?
Yes, sir. Soil trust.
Soil trust, as I told you, soil trust, it is putting a little effort to sensitize the general public. Now I am working with farming community. I am working with college students. I am working with farm unions. I am also working with consumers. I am also initiating a dialogue with the people representatives. So I am sensitizing the issue of soil and the importance of soil microbes at different levels. So while working with farmers, I am trying to provide them the technical information, practical demonstrations of improving soil health by making and applying to the soil, like composting with locally available resources. When I interact with students and college students and youths, I will make them to understand the importance, what as a student, as a youth, what is the role of them actually in conserving the soil. So while interacting with the administration, like institutions or Krishi Vignana Kendras, I am with the Gram Panchayats, I am asking them to establish a museum. A museum where you not only have different types of soil of that region, but also the native seeds, but also the insects, what they are seeing, but all those things. Museum is not only pertaining to soil only, it is also soil and it is related, things. And I am also having an interaction with our people representatives, MLAs and others, whom I am requesting them to raise the issues related to soil at the proper forum and in the proper forum, and try to influence or sensitize the policymakers also to bring eco soil friendly farming practices like that. So I am working at different levels. I means we have a small team. We are working at different levels, and I am still to be frank, the major problem I found when I wanted to work on this, that the information, that is the knowledge in the gap and resource gap, and still there is no much information about soil, whatever the other countries have now. And whatever the information we have already, it is just limited to the university level or research institution level, or at the at that level only. It has not gone to the farmers. We talk about the farmers should be, it should be scientific approach. We should take science to the farmers like that. But nothing is happening. So I am into that now. So while organizing such kind of a demonstrative training program, now to understand, to have a better impact of the program, I am also now using certain implements related to soil. They say other is that there is a tube which you can take soil sample, and engaging the children actually. I will take different colors of soils, around 8 to 10 types of soil colors. I will filter it, what you call, and then I will add a little water and gum to that and make a paint, a soil paint. And I will give white sheets and brushes to the children, students, and ask them to draw whatever the paintings they would like to have. What they see in the soil, I ask them to draw. And I will ask them to use all the colors to draw a picture. Then by doing this, I will encourage them. And I will also put water to the different colors of soils, and dip the white cotton cloth. It is a bag or a banian or a kerchief or whatever it is, shirt. And after that, half an hour, I will dry it without squeezing it. When it's totally dried, the white cloth will have a patches of the soil color. It is natural. So in this way, I am trying to, attract more people, more communities into this matter. Thank you. Hello? Hello, madam?
Yes, sir. Thank you very much, sir. We have now completed the round of questions. On behalf of agricultureinformation.com, we like to thank Mr. P Srinivas Vasu for the talk and for answering the questions in detail. I like to also thank all the participants in the meeting. This meeting will now be closed.
Madam, how many people are there?
Sir, as I informed you, participants have logged in from our website, sir. So we'll not be knowing how many are there. Okay.
But I would like to know their reaction about the
Yes, sir.
presentation.
We have also shared your contact details. If there is any query or if they wanted to get in touch with you, they will be in touch with you, sir. Okay.
No, just to know whether I can take this particular presentation to other places also, whether it is really shareable or something like that. That's why.
Yes, sir. We will share you the recording of this meeting. Okay.
Thank you. Thank you very much.
Thank you.
Each and
You're
everyone.
welcome, sir. You're welcome.
Thank you
sir.
very much for the opportunity. Yeah. So shall we close it now?
Yes, sir. I will close the meeting now.
Thank you, ma'am. Thank you, everyone.
You're
Bye.
welcome, sir.
Bye.
Bye.
Bye.